find the value of tangent square pi over 7 plus tangent square 2 pi over 7 up to tangent square 2023 pi over 7. You may use the chapters below to jump to the section of thinking process and different parts of the detailed solutions.
Hi there, welcome to my channel Matheism. At the beginning of New Year, I want to share with you this question of 2023, which is a series of tangents. The idea of this video credits go to one of my best friends, Stephen. Thank you very much. You may want to check out another question about tangents in the same playlist. See the link above. Without further ado, let's get started. First of all, we notice that the period of tangent theta is equal to pi, so we can put 7 terms in a group. For example, the first group is from pi over 7 to pi over 7 up to 7 pi over 7. And the second group is 8 pi over 7, 9 pi over 7 up to 14 pi over 7, so on and so forth. The sums of tangent square of each group are equal. Moreover, because 2023 is equal to 7 times 289, therefore, there are 289 groups of same value. Now, let's focus on the first group, pi over 7, 2 pi over 7, up to 7 pi over 7. Because tangent square 7 pi over 7 is equal to tangent square pi, which is 0, therefore, we only consider 6 terms from pi over 7 up to 6 pi over 7. Furthermore, because tangent pi minus theta is equal to negative tangent theta, so squaring both sides, the negative sign on the right disappears. Therefore, tangent square pi minus theta is equal to tangent square theta. Putting theta equals to pi over 7, 2 pi over 7, and 3 pi over 7, we get these results. In other words, the sum of first 3 terms is equal to the sum of the last 3 terms. So we can just focus on the first 3 terms. Finally, we're going to set up a cubic equation with roots tangent square pi over 7, tangent square 2 pi over 7, and tangent square 3 pi over 7. Then we can find the sum of 3 values by Vieta's formula of roots. In the cubic equation, ax cubed plus bx squared plus cx plus d equals to 0 with roots alpha, beta, and gamma, then the sum of roots is equal to negative b over a. Therefore, we can find the value of tangent square pi over 7 plus tangent square 2 pi over 7 plus tangent square 3 pi over 7. That's all about the thinking process. Let's jump to the detailed solutions. In part 1, we're going to obtain a formula of tangent secant theta in terms of tangent theta. To make the steps simple, we let t equals to tangent theta. Therefore, tangent secant theta will be in terms of t. By double angle formula, tangent 2 theta is equal to 2 tangent theta over 1 minus tangent square theta. In terms of t, this is equal to 2t over 1 minus t squared. Let's call this equation 1. Now, let's work out the formula of tangent 3 theta, which is equal to tangent bracket 2 theta plus theta. By compound angle formula, tangent a plus b is equal to tangent a plus tangent b over 1 minus tangent a tangent b. So we put a equals to 2 theta and b equals to theta into the formula. So tangent 3 theta is equal to tangent 2 theta plus tangent theta over 1 minus tangent 2 theta times tangent theta. Putting equation 1 of tangent 2 theta and t equals to tangent theta into the expression, then this is equal to 2t over 1 minus t squared plus t in the numerator over 1 minus 2t over 1 minus t squared times t in the denominator. To simplify the fraction, multiply both numerator and denominator by 1 minus t squared. Then it is equal to 2t plus t times 1 minus t squared in the numerator and 1 minus t squared minus 2t squared in the denominator, which is equal to 3t minus t cubed over 1 minus 3t squared in the denominator. Next, we're going to find the formula of tangent 4 theta, which is equal to tangent 2 times 2 theta. Apply the double angle formula for tangent 2x. We put x equals to 2 theta. Then tangent 4 theta is equal to 2 times tangent 2 theta over 1 minus tangent square 2 theta. Putting the expression of tangent 2 theta into it, then it is equal to 2 times 2t over 1 minus t squared in the numerator, and in the denominator it is 1 minus bracket 2t over 1 minus t squared whole square. Again, to simplify the fraction, multiply both numerator and denominator by 1 minus t squared whole square. Then in numerator, 1 minus t squared is cancelled out. Then it is equal to 4t times 1 minus t squared in the numerator, and in the denominator 1 minus t squared whole square minus 4t squared. Expand and simplify. This is 4t minus 4t cubed over 1 minus 2t squared minus 4t squared is minus 6t squared plus t to the power of 4. Lastly, for tangent 7 theta is equal to tangent 3 theta plus 4 theta. By compound angle formula again, we have tangent 3 theta plus tangent 4 theta over 1 minus tangent 3 theta tangent 4 theta. Put the two expressions of tangent 3 theta and tangent 4 theta back. We shall use red for tangent 3 theta and green for tangent 4 theta. Then it is equal to the following. At this point, we do not have to simplify it, as you'll see in the next part. In part 2, we're going to set up a cubic equation with roots tangent square pi over 7, tangent square 2 pi over 7, and tangent square 3 pi over 7. Let's start with tangent 7 theta equals to 0. Because the period of tangent theta is equal to pi, therefore, for the equation, we consider the range. 7 theta is between 0 and 7 pi. Solving the equation, we have 7 theta is equal to 0, pi, 2 pi, up to 7 pi. Divide both sides by 7, we get theta is equal to 0, pi over 7, 2 pi over 7, up to 6 pi over 7, and pi. As the original series starts from pi over 7, so we'll get rid of theta is equal to 0. Let's look at the equation tangent 7 theta over tangent theta equals to 0. By doing so, the two roots 0 and pi are rejected. It is because if we put theta equals to 0 and pi into the denominator, Then we get tangent 0 and tangent pi both are 0. So the denominator is 0, which is undefined. Then we have only 6 roots. Theta is equal to pi over 7, 2 pi over 7, up to 6 pi over 7. Next, we're going to express the equation in terms of t. We put t equals to tangent theta and the formula of tangent 7 theta in part 1 into the equation. Then we'll get this. A large fraction times 1 over t is equal to 0. Cancel out the t in the numerators like this, and multiply the large denominator to the right hand side. 0 times anything is 0. Then we'll get a much simpler expression like this. Next, combine the two fractions by multiplying the two denominators on both sides. This is equivalent to cross-multiply the denominators to the numerators. Then we'll get this. Observe the largest power term, which is t squared times t to the power 4, which is t to the power 6. There are at most 6 real roots of this equation. Moreover, because t is tangent theta and theta is equal to power 7, 2 power 7, up to 6 power 7. Therefore, the 6 roots of the equation are tangent power 7, tangent 2 power 7, up to tangent 6 pi over 7. We're going to further reduce the power of the equation. Let x equals to t squared, which is tangent square theta. Then we get this. 3 minus x times 1 minus 6x plus x squared plus 4 minus 4x times 1 minus 3x is equal to 0. Expand and simplify. We expand in such a way so that it's easier to group the like terms. We'll do the same for the second term. Now we're ready to simplify, so 3 plus 4 is equal to 7. Negative 1, negative 18, negative 4, negative 12 gives negative 35x. 6 plus 3 plus 12 is 21. X squared minus x cubed equals to 0. Therefore, we get the equation x cubed minus 21x squared plus 35x minus 7 equals to 0. Let's check out the roots of this equation. Because x is tangent square theta and theta is equal to pi over 7, 2 pi over 7, up to 6 pi over 7. Therefore, the roots of the equation are tangent square pi over 7, tangent square 2 pi over 7, up to tangent square 6 pi over 7. However, this is a cubic equation with at most 3 real roots only. Indeed, some roots are equal. Because tangent square pi minus theta is equal to tangent square theta, if we put theta equals to pi over 7, 2 power 7 and 3 power 7 into the identity, then we'll have the following results. We can see that 1 and 6 as a pair, 2 and 5 as a pair, 3 and 4 as a pair. Therefore, the 3 distinct real roots of the equation are tangent square pi over 7, tangent square 2 pi over 7, and tangent square 3 pi over 7. We can use this result to work out the series in the final part. In the final part, we're going to use Vieta's formula of roots. In a cubic equation, ax cubed plus bx squared plus cx plus d equals to 0, with roots alpha, beta, and gamma, then the sum of roots is equal to negative b over a. So for the previous equation in part 2, with 3 real roots, tangent square pi over 7, tangent square 2 pi over 7, and tangent square 3 pi over 7, then A is equal to 1 and B is equal to negative 21. Then the sum of roots is equal to negative 21 over 1, which is 21. Again, by the result in part 2, we have these 3 pairs: 6 and 1 as a pair, 5 and 2 as a pair, 4 and 3 as a pair. The first 3 terms is equal to the next 3 terms, while the last term is equal to 0. Therefore, the sum is equal to 2 times 21 plus 0, which is 42. Lastly, because the period of tangent theta is equal to pi, so we can put 7 terms in a group. The sum of the first 7 terms is equal to the sum of the next 7 terms, so on and so forth. Moreover, because 2023 is equal to 7 times 289, therefore we have 289 groups of same value. In other words, the required sum can be written as 289 times the first group, tangent square pi over 7, plus tangent square 2 pi over 7, up to tangent square 7 pi over 7, which is equal to 289 times 42, which is 12,138. So we found the series of tangents of 2023 in the new year. I hope you enjoyed this video. Please give me a like, share and subscribe my channel. I'm happy to see your views in the comment section below. That's all I have for you today. I'll see you next time. Bye.